for joining us for our session on Practical Security Incident Response on AWS. I'm Christine Miles. I am a security engineer within the AWS Security Cloud Response team. We're a global team that are actively responding to issues to keep our services and customers safe 24 hours a day, 7 days a week. Today, we are going to talk about the goals of incident response and the importance of being prepared for incident response. We are joined by Andrew Bennett, Head of Product and Cloud Security at Seek, who will take you through their incident response journey in the cloud. Have you ever stopped to think about what the goal of incident response is? Ultimately, we want to be in a position where we no longer have to perform incident response, moving from being reactive to preventative. But how do we get there, and what are the building blocks we need? First up, we need to be prepared, ensuring we have security controls in place, having visibility to provide contextual awareness within your environment, and of course, having a response plan. We need to promote good security culture by fostering good relationships. Having the capability to quickly identify a security incident has occurred and be able to investigate and dive in to understand what has occurred. Being able to respond to and contain an ongoing incident in order to reduce any negative impact while working with other teams to eradicate the root cause. Recovering from the incident and bringing our systems back online at full capacity or restoring any lost data as quickly as possible. Finally, learning from incidents or near misses, which enables us to evolve and mature our response processes. Preparing for an incident involves both technical and human building blocks. It begins with planning and developing good security culture to enable you to have those technical foundations we need. Let's begin by having an incident response plan. Playbooks are your organization's plan to respond to an incident, the things we're going to do given an event occurs. This may include a communications plan, a PR plan, and may reference multiple runbooks. Runbooks are more specific and detailed. They guide incident responders on how to deal with specific issues. Runbooks help provide consistent responses and in many cases can eventually be automated. So what does a good playbook or runbook look like? Firstly, that they exist and are in a standardized form that is readily available to your incident responders. They are kept up to date and updated by incorporating feedback from the last time you used it. Ensure you test them. You can practice by running simulations, game days, and tabletop exercises regularly. Take feedback from these and iterate on them. Now that you have a written process of steps, these can be translated to automation. Mature runbooks allow automation of your response, freeing up your responders to work on more critical alerts and incidents. Culture and attitude are things you will not often find in an incident response playbook, but you need to prepare your organization for incident response. Security culture needs to be driven top-down from senior leadership through advocacy, policy, process, and communication. Leadership support can really drive the success of your incident response journey. Educating your organization on your security goals and outcomes through awareness, training, and seeking feedback helps the people around you that you may need to rely on during an incident to understand what incident response is and helps to foster those relationships you'll need to call on during an event. Communicating often. You should treat every security incident as an opportunity to learn and evolve. An often forgotten step of the incident response process are post-incident reviews. These are the learning opportunities. They are the most critical. They help identify gaps to improve your IR process. Seek feedback from a diverse range of stakeholders. Understand where communications may have broken down and what the customer pain was. So how can technology help you be prepared for incident response? The first place to start in AWS is to check out the well-architected security pillar. The security pillar describes how to take advantage of cloud technologies to protect your assets in a way that can improve your security posture and ultimately ensure you can meet the goals of incident response in your AWS cloud environment. The well-architected security pillar guides you to set up security foundations within your AWS environment, from preventative security, including identity and access management, infrastructure protection and data protection, through to response capabilities, detection and incident response. Putting an incident response lens on these security areas, your maturity across the first four will directly influence the fifth, incident response. It's a continuous cycle. Once you hit the IR pillar, the outcome of a response scenario will in turn likely inform changes you need to make across the first four. For example, rescoping identity permissions, or increasing protective controls, or implementing new monitoring and alerting mechanisms. As an AWS security engineer, part of an amazing global response team, I'm quite often asked this exact question: what is the secret to successful incident response? What I can tell you is that it's no secret at all. Communication, contextual awareness, and the ability to learn and evolve are the building blocks to successful incident response. So what are my lessons learned from the field? Recognizing that you have to start somewhere and know where that somewhere is. So be prepared, have a plan and iterate on it. Know your environment, what normal is, and what assets need protecting. Monitor and tune your alerting so you aren't suffering from alert fatigue and you're responding to true positive detections. Communicate and iterate on your processes, and ultimately automate as much of your response as you can. Now, it is my pleasure to invite Andrew, the Head of Product and Cloud Security from Seek, to share Seek's incident response journey and the building blocks they were able to put in place that enabled them to evolve their incident response program.
Thank you, and thanks for the opportunity to talk today. As Christine has just mentioned, my name is Andrew Beanett, and I'm actually super fortunate to work with the awesome security team at Seek. Today, I wanted to talk a bit about some of the foundational work the security team has done around IR, or incident response. Many people in Australia know Seek, and a lot will at some point in their career have had an interaction with us. If not to look for a job, then perhaps in hiring for a role in your organisation. What a lot of people don't realise is Seek is a much larger and diverse group of companies spanning some of the most populous markets across the globe. We have interactions with nearly 250 million job seekers and 1 million hirers worldwide. So understandably, security in order to protect customer data is a major priority for us. As Seek has grown over the past 24 years, expanding through investments and acquisitions, so has our technology footprint. As you might imagine, this has also resulted in the obligatory legacy system issues, but has also created a complex technology environment, which is why good incident response foundation is so important to us. Having context and awareness of your environment is absolutely critical for any security team. This context enables an IR team to more rapidly identify, contain, and recover from an incident. This presentation, though, is not specifically how Seek responds to incidents, but focuses on the foundations which we believe are critical for good IR. And the story of how we got where we are today is somewhat tangential, but more interestingly, incident response wasn't actually our original goal here. But as I hope to demonstrate, became a key piece of the IR puzzle for us. So way back in 2014, Seek had made a decision to move from the traditional data center to cloud. This decision was largely driven by the desire to be able to innovate and deliver products faster. From a technology footprint point of view, we had seen a rapid growth in the number of AWS accounts. Over a 6-year period, we had grown to well over 200. It's worth calling out at this point that we were deliberately aiming for a multi-account strategy. It's an approach which we believe provides great security isolation boundaries, as well as helping to contain operational blast radius. From a security point of view, though, we felt we were falling behind in understanding the threats and risks in our environment. During that same time period as our accounts were growing, we also had an explosion in the number of IAM users and associated access keys. By around 2018, we had in the order of more than 1,000 access keys across our accounts, and this represented quite a significant security risk. So what were those risks around access keys? Firstly, control over how and where they are stored. They inevitably end up on laptops and workstations and can even end up in email and Dropbox accounts. Keys are sometimes mishandled or compromised. When that happens, it can be incredibly difficult to detect and differentiate malicious from non-malicious use of a key. And they also never expire, and generally, the longer a key exists, the more likely it is to be subject to misuse. They can also get orphaned and forgotten, which happens to compound the problem. Finally, operationally, they are really horrible to deal with. If you need to disable or rotate them during an incident, it can be difficult to assess the impact, and it's likely you'll end up taking key services offline. We pretty much faced three options to drive down the use of access keys. The first was the big bang approach. Turn them all off at once. This really wasn't an option because, as I already mentioned, bad things would probably happen to production. We could have gone team by team, but we decided this was going to be a very inefficient approach. But the option we settled for was to kick off a company-wide initiative with clear expectations. We got leadership and stakeholder buy-in and provided the organisation with measures of progress. And it's this last point, the measures, which both allowed us to successfully deal with the issue at hand, but it is also what helped lay the foundations for our incident response capabilities. We ended up creating a clear goal and an internal standard for the use of IAM access keys. We used a simple method of expressing our security objectives, which was easy to communicate and made it easy for stakeholders to understand. But most importantly, it was framed in a way which allowed the goal to be measurable and visible. We then set about looking for a way to accurately report on non-compliant access keys in all accounts. What we landed on was to implement a basic automation process to give us insights into IAM. Over on the left of this diagram are all the member accounts, and on the right is an account we call Account Central. The very first use case for this process was to gather IAM credential information from all our member accounts. We have a Lambda function in Account Central, which triggers the IAM credentials report function in each member account, takes that output and writes the results into an S3 bucket. This then allows us to really easily query the output data with Athena. This is an example of an SQL query we might use. This one here is saying, give me a list of all the IAM users across all accounts which have console access and no MFA set. And we used several queries like this during the initiative to remove the access keys. Once we had built that, it quickly became apparent that what we had built to address the problem of IAM access keys could easily be extended to provide more context for many other AWS resources. The diagram here shows just a very small sample of AWS resources we collect data for. But we gather data on over 50 services such as EC2, S3, Route 53, and RDS. This system also became really helpful for incident response, as it allowed us to answer questions quickly without logging into each account individually. Traditionally, security has focused on servers, networks, and applications, but in terms of asset management, it's worth keeping in mind that the cloud has the additional layer which exposes all those other resources, such as your S3 buckets and DynamoDB tables. These are assets which are just as critical to understand in your environment, but just work at a slightly different layer of abstraction. The benefit of the cloud, of course, is that virtually all this information is also exposed via our APIs. Here is another example of an Athena query we might use to apply during an incident. The question might be to find all EC2 hosts which have an IP address with 10.0.0.star. It's worth noting, some of what we built here predates services like Security Hub, Macie, and Amazon Detective. And this particular query, for instance, would probably be better answered today using Amazon Detective. However, from a pure asset management point of view, this database is still really valuable to us. So if we step back a little further, the resources data collector I've been talking about is really just part of a bigger set of centralized services. In the diagram here, centralized security and infrastructure services are depicted on the left, and the right are all the member accounts again. These centralized accounts allow us to do things like apply service control policies. For example, We do things like deny root login, we deny access to AWS regions that aren't used, and we prevent tampering with security controls like config, logs, and IAM roles. We also, from here, can provision our base security roles. We can set up guard duty, we configure VPC flow logs across all our accounts, and we deploy AWS config rules in all the member accounts as well. It also provides a place for centralized logging, and this includes application logs, obviously CloudTrail, as well as VPC flow logs. And an interesting capability this gave us is the ability to scan and alert for accidental recording of sensitive information in our application logs as well. We also use CloudWatch event rules and EventBridge to capture specific events of interest for real-time response or notification. I'll touch on more of this shortly. Finally, with all these insights and logs, we have actionable information which we can apply to automated remediation. And it's the remediation part I'm going to talk about next. But just before I dive into that, where did we get to with our IAM initiative? So after 6 months, with the focus on the right information and measures, as well as a lot of hard work from the teams at Seek, we had successfully mitigated our IAM risks. The age of all access keys were now less than 90 days, with some exceptions. We also found that about 80% of all our keys could just simply be deleted. They had no use anymore. The initiative also included removing keys from source code. But we didn't want to be in a position where we had to fix this problem again in 12 months' time. So our next focus was ensuring we remained in a compliant state, which speaks to the last part of our goal, keep it there. We continued to build upon all the previous foundations and started to deploy automated remediation. The way this works is Account Central deploys AWS config rules into all the member accounts. One of those is a rule that access keys are required to be less than 90 days old. All of the AWS config compliance events are then aggregated back to a security account via CloudWatch EventBridge. These events are processed by a Lambda function, and any IAM access key older than 90 days is simply automatically deactivated. In fact, whenever any of our config compliance events is triggered in any of the member accounts, it is received by our central security account and handled by that Lambda function. Once again, we found we had built some infrastructure which had a more general purpose use. So what started as a system to auto-remediate IAM access keys with a single config rule quickly expanded to deal with other events. We added events of interest from sources like guard duty, KMS, and console logins. We also monitor configuration changes in Route 53 because we run a public bug bounty program that really drives us to detect and mitigate dangling DNS issues as fast as possible. All of these events received in the security account can be filtered for immediate action, routed to services like Splunk for querying, or Slack and PagerDuty for notifications. Overall, there are quite a few key AWS services we leverage. For events and logs, we make use of CloudTrail, config rules, VPC flow logs, guard duty, and CloudWatch events, and more recently, we've enabled Security Hub. For storage and query, we make heavy use of S3 and Athena. We're also using Splunk to query that data. And in some cases, we've created quick site dashboards and reports. For automation, we're using Lambda, and in some cases, some step functions. And finally, on the notification side, we're using PagerDuty and Slack. In the end, there were some really good lessons for Seek. Firstly, uncovering and shining a light on the dark corners of our environment gave us the visibility and asset management capabilities we needed. Secondly, being able to query data and reason with resources and infrastructure was invaluable. Thirdly, we put in place a really solid and critical foundational piece for our IR. That is, collection of logs, and just more logs. In some cases, we don't even have the capabilities to process or alert from logs in real time, but just capturing and storing them has been valuable during forensics investigations. Finally, using all this contextual information to provide timely, relevant, and actionable information has enabled us to build trust with key stakeholders, as well as learn and improve our controls. So on that note, thank you for your time, and now I'll hand back over to Christine.
Thanks, Andrew, for sharing the success story with us. What I enjoyed is how you started in a situation many organizations are in and were able to leverage AWS to give you the visibility and context to achieve a single goal, which ultimately puts Seek into a position to grow and significantly mature your incident response program, leveraging tooling and automation. Next, I'm going to run through a typical response scenario for someone running workloads in AWS. With just some basic preparation, you can see how you can get started today. Remembering earlier the importance of having a plan, and this is ours. Prepare, identify and detect, contain and eradicate, recover, learn and evolve. For this scenario, we enabled some basics such as IAM to manage our authentication and authorization, AWS CloudTrail for logging, Amazon GuardDuty to detect, and response runbooks. Being prepared allows us to identify and detect a security incident has occurred. Here we have detected and identified a potential security issue from Amazon GuardDuty. Here we can see GuardDuty has detected some suspicious activity in our account. You may have set up CloudWatch events to receive alerts via email or delivery to your on-premise SIEM tool. The alerts appear to relate to S3 and a single identity. The key things I see here are public access blocks have been disabled and public access has been allowed. Now, because we're prepared, let's check out the runbook to see how we proceed. Do I have a matching runbook for this scenario? This is a sample runbook with some of the key components you may need, but you can customize a runbook to your unique needs. We'll share with you some sample runbooks at the end of the talk. So as you can see, this runbook outlines what data we might want to gather, such as CloudTrail and S3 access logs, how we would investigate and analyze the data, essentially what questions need to be answered, how to communicate to stakeholders that an incident has occurred, and what steps we can take to contain the incident from further impact. So let's begin our investigation and look at the first finding using the GuardDuty console. What jumps out here to me is the disabling action, the S3 bucket name, and user identity. There's also a short explanation of the finding provided by GuardDuty. The bucket name to me, keyword being salaries, indicates that some sensitive data may exist in this bucket, so we should continue to investigate. Using GuardDuty to dive into the finding, we get more detail into the affected resource. The detail can answer questions such as what account this is in, what resource was affected, what action or API was invoked, and the source IP of the action. Let's move to our second finding. Similar to the first one, having a low severity, same affected bucket and user identity, but this time we see that the S3 block public access control has been disabled. Let's go directly to the source this time and have a look at the contents of the raw log for this finding in CloudTrail. This time I've filtered CloudTrail events by the affected resource name and have found 3 actions, which you may notice also relate to the 3 GuardDuty findings. Diving into finding 2, S3 block public access disabled, we can see the exact configuration that was set. You can see all 4 options of BPA have been disabled or set to false. These findings have led to this final critical finding, which was to grant anonymous public access to the bucket. So what do we think this person can do? They have turned off access logs and made an entire bucket publicly accessible without authentication or authorization, inferring here that access to the bucket may not be traced and can be accessed by anyone, anywhere via the public internet. Depending on your runbook and other factors, you may want to investigate further. Understanding more about the remote IP, investigating whether the user was compromised or if this was an internal threat, investigate why the user had the permissions to change the access controls to begin with, or investigate if the bucket contents were accessed or tampered with. However, at this point, I have an understanding of what has happened and the potential impact, so want to move directly to containment. Now, depending on your incident, these are some of the actions you can take. In this case, we need to isolate our resources. In other words, we need to restrict public access to the S3 bucket and contain the user identity. S3 block public access provides controls across an entire AWS account or at the individual S3 bucket level to ensure that objects never have public access now and in the future. We can use this option to contain our bucket. So, by accessing the S3 console and selecting the affected bucket, we can re-enable the S3 block public access control, or BPA, on the affected bucket. Next, we will contain the user by either rotating their credentials, removing their permissions by detaching policies, or disabling their access. Once you've contained the identity and secured your data, you can continue your investigation into how this happened, if data was accessed or tampered with, and so on. On to our lessons learned now. Some questions we may ask once we've finished investigating and recovered from the incident include, did we fix this issue? Do we need additional preventative controls? Did we communicate well? Do we need to implement or supplement our monitoring and alerting? Could we enrich data for the original alert to cut down the time we are investigating and digging through log files? Do we need to update our runbooks? An outcome of this may be to understand how to stop this from happening again. At a local account level, ensure S3 block public access is applied on all buckets in your account and review who is permitted to disable it. Introducing config rules into the account to detect and apply automation, all the actions we took can be automated by your chosen trigger. Thinking about your defense in depth here, not permitting users to disable the feature, alerting if it is disabled, and then automating the re-enablement of BPA. But remember, every incident is an opportunity to learn. So the big question is, how can we stop this from happening again in any account across the entire organization? One option is to centrally manage your security controls, just as Seek have done, by using AWS Organizations and Service Control Policies, or SCPs. Now, I want to leave you with resources that will help you mature your incident response building blocks. Things you can do no matter where you are in your incident response journey is taking a look at the well-architected security pillar and performing a review to identify any gaps in your security foundations. Practice by checking out the well-architected security labs. And of course, check out the AWS Security Incident Response Guide and start building out your response arsenal with some of our sample runbooks. Now, you joined AWS Summit to learn, and you can keep learning beyond the summit with resources from AWS training and certification for security. You can also showcase your expertise by pursuing the AWS Certified Security Specialty Certification. Thank you for joining us for today's talk, and a huge thanks to Andrew for sharing Seek's journey with us. Before you go, your feedback is important to us. Please complete the session survey for today's talk on practical security incident response on AWS.